How's it going, everyone? Welcome. Elvira Gonzalez. That's right. So, let's take a look now at the Model 2 of CSS for JavaScript developers, which is a course written by Josh Komiwa. And in today's video, I want to now dive deep into this particularly model, which is rendering logic 2, as a way to understand now is another layout, um, another layout algorithm, or in other words, another way how now CSS define is how this element from the document is going to be rendered on the screen, right? Not only as a box, right, and how each one of those boxes relate to each other, is also going to, it's also, it matters is where those boxes are now, in which context those boxes are, right? So by default you have is the normal flow layout, which is made of two blocks, it's made of three blocks, and it is behaviors, right? So you have now the block, the inline, and the inline block, and the block, they behave in a particular way. So each one of them has its own behaviors, and that is the block is gonna take all the available space horizontally, all right, and also is the inline is gonna fit the content, aka is gonna take only the available space, and if that goes beyond the viewport, which is in this case is this might be the viewport. If this go beyond the viewport, it's going to now line break that. It's gonna put the content right above. And also and how other elements actually behave like this, how particularly elements like image, videos, canvas actually behave like an inline elements, and some of the nuance and quirk and things that we want to avoid when you're working in that normal flow. And also is the inline block. So unlike the inline that you can modify its dimensions, with block you can modify its dimensions, but it doesn't line break the content, unlike inline. So block inline actually is a mix of that. So so um, so back in this course on the CSS and so on and so forth, I also look at now how these boxes behave, as I mentioned with the block, inline and inline block, and also is how the anatomy of this box actually relate to each other, and what is and how now this behave according to other elements. So for example, the negative margins and the margin collapse. which is something that happens only in this normal flow, and they collapse is on vertical. The collapse is now in vertical elements, and there's some couple rules that I do want us to actually explore later on, but not in this video. But the idea is that get yourself familiar is first what CSS is, the cascading effect, which is the way of how now CSS resolve competing CSS declarations and rules. What is a CSS rule? And then well, now dive deep into the box model, or in other words, is this particularly the anatomy of your tool, especially of how you're going to now draw elements and position elements on the screen. So right now in today's video, we're going to now explore about is this, right? Let's get into this rendering logic. Okay, so so in the last model, we learned about flow layout, and it is the OG flow layout algorithm of the web, but it's not alone. In these sections, we're going to look at another layout mode known as position layout. The defining feature of position layout is that items can overlap. So that's the whole point of this position layout. The flow layout algorithm tries very hard to make sure that multiple elements never occur the same pixels. With positioning layout, however, we can break out of the box. Exactly, with position layout, however, we can break out of the box. But the flow layout algorithm tries very hard to make sure that multiple elements never occupy the same spot, the same pixels. With position layout, however, we can break out of the box, and we can opt in position layout using the position property as it is. It can be set to relative, absolute, fixed, or sticky. Each one of works in a unique way, like a mini layout algorithm within the layout algorithm, which is within the position. This is why when Josh Comeva, the author of this course, mentioned is that CSS works more like a set of mini language rather than a concise or rather than a unified language. Exactly, rather than with that. So the thing here is, so it makes exactly so. So for example, in the case of display, this is it makes. So the intuition is quite right, because as we explore about the normal layout and the absolute and the position layout, okay, the position and layout, we looked at each one of those properties describe now a set of rules there, right? That you can combine with, which is also that we're gonna see that and how to combine with other layouts. So we can opt into position and layout using position property, and it can be set to relative, absolute, fixed, or sticky. Each one works in a unique way, like a mini layout algorithm within the layout algorithm. In the lessons ahead, we'll explore all of these different variants to position layout. Static positioning. The default value of the position property is a static. Okay, the default value of position property is static. Occasionally you will see refers to statically positioned elements. All this really means is that the elements are not using position layout. Okay, occasionally you will see refers to statically positioned elements, and all this really means is that the elements are not using positioned layout. They are using some other layout modes like float or flexible or grid. If an element is currently positioned layout, if using positional layout and you want to opt out, you can set a position to either static or initial. But all of the elements have a default value of position static. Okay. And occasionally you will see refers to the statically positioned elements, and all this really means is that the elements are not using positioned layout. They are using some other layout mode like flow or flexbox. It's not using position layout. So they are all using other layout modes like flow, flexbox, or grid. If an element is currently using position layout or you want to opt out, you can set up the position either to static or initial. Then you talk about now the relative positioning. All of the position layout subgenre relative is the most subtle. Position relative. You can often slap position relative of an element and observe zero difference. It appears to have no effect. In fact, it does two things. Constrain certain children, so we'll get to this shortly, and enable additional CSS property to be used, especially with the relative position. Yes. So when we opt into positional layout, we enable a handful of new CSS property, including the top, left, right, and bottom. We can use those directions values to shift the elements around. With relative position, those values are relative to its natural position. It is common to use top and left to push things along to the vertical and horizontal axis, respectively. Setting left 10 pixels, push the element 10 pixels to the right. Focus the blue box below and use the arrow key to shift it around. This blue box is interactive. So you can focus that, you can focus on this element here. Yes, you can focus on this element here. Position relative, as you can see, and marking it 30 and 0 pixels. 30 on top and down, and there you got it. Position relative, and position relative are all of these elements, as you can see. And then you have now a bottom here. Okay. Yeah, to me it was like, how do you focus this? Okay. It's because this is now a bottom. But that's interesting because the animation here, okay, of this bottom, it's something like this. The outline here is this. So if you don't have now, it's not going to add any outline here. And outline here is this. That's interesting because you can now the question is that you can now add outline here. So for example, outline here of 2 pixels and blue, right, of this element, okay. I do think it is this. So outline require is at least 1 pixel. to describe that. So outline here is 2 pixels, blue, or you say solid, exactly, because this outline behaves somewhat similar to the border. 2 pixels, you can also specify how much you want, solid, and then the color of this, right? But also you can say, hey, if this is now hover, you do want to now have a provide this, right? Provide this on hover. So you can emulate, say on hover. This is the style that I want to add here on hover, right? And then you got it. What I do want is to apply this on hover for specific elements. That's interesting. How can I force this on hover, right? Okay, this is to apply to both of them, that's right, but I don't want to apply to both of them. I don't want to apply is when the hover occurs. Okay, so when the hover occurs, this is what I do want to simulate, right? Okay, or unless you say now on focus here, but that's quite interesting, right? At least of how this button actually focus it is, or apply that style here. You know, you have is this, but it's on the button that it says that, and offline offset. This outline appears here, but that's quite interesting that it appears when the element is focused. Exactly, on focus you get this. Okay, so this was now a style that was added here. Okay, so I also can say something like this and say, hey, when this element is now hover, okay, hover, I do want to apply now this, right? But because this element is not hover, so when it's hover, now it's actually applying to this. Okay. Okay, I do need to specify on the browser it worked this way. Okay, cool. So on hover it actually put this, and also as well. So you can also use negative number to push the elements in the opposite directions. For relatively positioned nodes, left -10 has the same effect as right 10 pixels. You might be thinking that's cool and all, but I can already push an element around with margins. What's the difference? Beware with this, bro. Beware with this, bro. The difference of pushing elements in using the positioning layout, unlike margin, is that you are modifying is the dimension of this element, which is what happened is with the What happened is with the layout, with modifying the margins, with position, it doesn't impact the layout. Notice in the visualization that the gray boxes are above and below, representing siblings elements. Don't move. They don't get pulled along for the right as they do with margins. So when we push relatively positioned elements around with top, left, right, and bottom, the browser acts like the element is still in its original position. The displacement is purely cosmetic. Compare them into the background. So when you have now this element, this is the natural flow, all right, or the flow layout. Okay, so the algorithm now is say, okay, this element, the natural, is gonna behave like the it has the default behavior, that is the flow layout. So all of these elements must stack next to each other, right? Especially the pen of the element, in this case a div, they're going to stack next to each other, right? Because they are now act as a block here. So good. So for example, if you somehow now modify is pink elements or pink block, and then you say, hey, I do want to actually is now make, so display these elements as an inline element, all right? Say display inline, display block or inline. It won't have any impact, okay? Because that element, the spy that is now in it is in that position is so what is going to be effective is the nested elements inside of that. So in other words, if I do something like this, all right, that's interesting. It's supposed to work, right? Display inline. Exactly, display inline. Oh, so I do need to but okay, because I specified the width of this box of 48. All right, and if I say width auto to actually fit this content here, so I'm indicating that now the width of this element won't be the 48, it will be now as the available content here, right? If for some reason now I do want to actually is make these elements to fit this content, which is now the box, all right, but because the box here is following is the normal layout, right? If I do this, say display block, it won't have any effect, all right? And in fact, it's saying that the elements here, it will act now as a block. All right, all the children will now act as a block here. So if we want to now fit this content, here we can say is inline block to do this. That's quite interesting. But if I do want to fit this content here, I can say is line break by word. But it's interesting here why this is happening. This is a very good question. Why this is not breaking is the content as it is? Well, because the content is too large to fit in that. But if you add now in space, now the content fits, right? If you put this like this, so the content is gonna take so because now the width and height is now set to that. That's how these things actually work. It's like say, hey, putting all of the dimension of this box is 48 by 48, the content in itself must fit here, right? So if you, for example, now add this display inline, right, and you somehow is now enhance is a little bit the width, all right, let's gonna put it this way. It's gonna put it this way. Exactly. As you can see, the content now is next to each other. This is what inline does. But if we change that to a block here, because this content takes all the available space, it's acting in this way. So the thing here is that if for some reason, right, we add now something like this. If we wrap this content into a element that is a block, this is exactly what happened. But if we wrap this element into an element that act as an inline element, it will of course take all the available space and gonna put it in this next to each other. All right, so I do think that's quite interesting to illustrate how the things work, right? It's gonna return that to whatever it was, 48. But the thing here is that this is the natural flow. This is what happens when you modify is the margin, which is AKA is collapsing here, is modifying is the layout of this element here. And this is not modifying the layout and is now overlapping this box over your content. This is live editable code, and play around and change some number to see what happens. Whenever we use relative position and top our margins, the pink box winds up in the same spot, 20 times pixel lower than it is natural position. With marginal top, though, the black boxes below the pinks once get shuffled along too, like a row of cars forced to back up to let a truck turn. Similarly, when block items don't have a specific width, like this, when block items don't have a specific width, they can dynamically resize when they say margin left is increased. Left, on the other hand, push an items around without even margin in its dimension. Okay. So with top, what it's doing is modifying is the position of that element, all right? But with margin, when the width is not defined, or when the width, when the width is not defined, it's gonna take all the available space in that regard, right? So for example, here, here, that makes a lot of sense. Here, if you say margin here, margin right, margin right is taking that. So it say, hey, I'm gonna take is this amount of space and this amount of space from left to right, and here's what I'm going to now draw this. So if we put now this auto, for example, now they are competing here. So if you say now this, right, for margin left and margin right, this will work is for margin as it is, all right, top and down here, and margin auto here. You say, hey, I do want is to now get all the available space here. So the width of this element will be something like 100 pixels, right? So this is when you define the this is when you define is the width. When you define the width of this box, and then you say now the margin say margin left is auto, it's gonna take all the available space, as you can see here, right? It's gonna take all the available space here and assign these sides to this. That's what it's doing the auto here. It's gonna take all the available space to this position. And because now when you do this, it's actually competing both of them. That's why interesting. Margin, because it's margin, it's not competing that. This is how you can now center elements as it is. Okay, again, here as we can see is that that margin is gonna stick to that. It's gonna respect the box boundaries. But if you, for example, now assign a elements to it and then you say, hey, the position or the layout algorithm will be now relative. In other words, it's going to now put on top of that, or as they mention here, is exactly the elements in flow layout never occupy is the same pixel, whereas with position layout it can be exactly with position layout. However, we can break out of the box. So how we can break out of the box. We cannot make elements. Okay, just to make just to be straightforward here, with position layout, it allows us to describe. It allows us to put elements on the same pixel. All right. This is when this things comes here. Okay. Play around and change some numbers to see what happens. Whether we use relative position and top or margin top, the pink box winds up in the same spot, 20% lower than its natural position, as I mentioned here. Notice how the right hand column box sweeps out the container, while the left hand column box gets narrower. Which of this is better, right? So, well, it is depend on the situation, and sometimes you want to shift an item around independently, and sometimes you'll want it to remain context aware. There is also a third option, using transforms. So which of this is better, right? Well, it depends on the situation. Sometimes you want to shift an items around independently. You can use margin to that. And sometimes you want to remain the context aware by using its margin. Or you can shift an item independently. There's also a third option, using transform, which is we'll learn about later in this course. Finally, it is important to know that relative position can be applied to both block and inline element. Exactly. This allows to notch inline elements in a way that isn't really possible otherwise. So we can now put is so we can now modify is the elements here. It's like we can now modify is the elements whether it's a block or inline. And then you say, hey, I want to make these elements appear here. Relative position opens some interesting doors, but we're just getting started with this layout mode. And let's take another variant, absolute positioning. So far, all the elements we have seen are laid out in an orderly fashion, one on the top of the another. We'll generally refer to this as inflow, as reference to the flow layout. Though these days it can also refer to the layout mode like flexbox. What if we want to break the rules though? What if we want to take an element out of the ordinary flow and stick it whenever we want it. In this case, absolute positioning is our friend. We generally use absolute positioning for things like UI elements that need to flow above the UI, for example, like tooltips, models, drop downs. Decorative elements that needs to be stuck in certain position, abstract illustrations, and stacking multiple elements in the same place, like a deck of cards. Let's start with an example. So we got here, the hello world, right? So if we say, hey, this is now fixed to this position, so pink box here, absolute. So yeah, we are now is saying this particular element, whatever element that contains this selector, it'll be now as a position absolute, aka I can now is it's an element that is going to occupy the same pixel as any other elements. Is an element that can occupy the same pixels. So for example, if we say now left, okay, this particular element is occupying is the same pixels as other elements. Okay, bro. In flow layout, we will expect the pink box to sit on top of the paragraph, since that's their order in the DOM, because our pink box use absolute positioning, though two things are different. The pink box is nestled up in the top right corner of the preview frame. The hello world paragraph has shift up to fill the space the pink box will normally fill, and let's look at them in terms. Wait, what? In flow layer, we will expect the pink box to sit on top of the paragraph. See, that's the order in the DOM. Because of pink boxes use absolute positioning, though there are two things that are different. The pink box is nestled up in the top right corner of the previous frame. The hello world paragraph has shift up to fill the space the pink box will normally fill. And let's look at another in turn. Placement based on the frame. This is the main thing people think about when it comes to absolute position. We can stick something in the corner or something position, something based out of the box, and it is being constrained by ignoring its natural position. We can do this with 4 properties: top, left, right, and bottom. Above, we stuck our box in the top right corner by specifying that it should be 0 pixel from the top edge and 0 pixel from the right edge. It doesn't have to be stuck along an edge, either consider it. Exactly, doesn't have to be stuck at that. So we're instructing the box to sit 20% pixels below the top. Exactly, sit 20% pixel below the top of the edge of the frame, and 20% away. Interesting how they do, how they describe here. So put this away from me, or put this below here. Sit below here. Sits below. And put it away from. So we instruct this box to put 20% below, sits 20% below the top of the edge, and 25% away from the left edge. The percentage is based on the total amount of a space available. It's just, to me, quite interesting how they mention, how they describe this. You know, it's 20% below. Is sit 20% below. This is part of the English here. It's sit 20% below the top edge and 20% away from the left edge corner. or the left edge. The percentage is based on the total amount of space available from that element, right? So for example, if that element you specify now, and that's interesting, because you can specify now the width of this element as 100 pixels. Good. So exactly, you are specifying is this element, this is the dimension it's gonna have. Okay. But if I do want to, okay. If I do want to specify now is the dimension of the of the let's say this is a section here. If I do want to specify now is the dimension of this, right? I can say, hey, this style here, I prefer to use now a class here, right? You say this is the container. Within this container, you say, hey, container, right? Okay. Exactly. This is now container here. Yeah, because I need to relax here. Yeah, I do need to relax here. Okay. I do need to relax here. Okay, I do need to relax here. Absolutely. I do need to relax here. I get it. Okay. So I do need to relax here. And doing it this way. Okay, so here in this container, I'm going to specify is now the width, and that'll be 100 pixels, right? And again, because now this element, this is interesting, because now this element is move away the normal flow, right? The question is that what are the rules that the absolute positioning is obeying? You know, what is the reference that is using here, right? In this case, I'm assuming that the reference that is using is, we say, the HTML here, and then you say the HTML is 100% pixels, and then you inspect that, or something like this, and then you inspect that here. The HTML is that, all right? The HTML is that, because now it's embedding that. The section is there, and the element now is drawing here. So now the reference that is using is the viewport, all right? Notice how this is totally different mechanism from relative position. Absolute positioning elements are adjusted based on their container, not based on their flow position. Based on the container, Oh, okay. So if I in this case say something like the container, and if I say, hey, the container that you want to now have a reference is 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 this. Uh, Now things change a little bit. So what we're saying here is that, hey, the max width of this element will be this, and I want you to now is okay, and I want you to now is use use that and the height here and the height here, right? And it say now this particular box is gonna be here, and the bigger the box is, the more sense it'll make to actually is there. So again, the reference that it takes is now the relative elements, right? Notice how this is totally different mechanism from relative positioning. Absolute positioning elements are adjusted based on their containers, not based on their flow position. To really drive the point home, try cutting and paste the pink box to above the paragraph in the HTML. Notice that it doesn't change anything in the rendering output in this case, right? Position absolute here. Okay. Notice how this is totally different mechanism from relative positioning. Absolute positioning elements are adjusted based on their container, not based on their flow position. Cut and paste this box so that it sits above the paragraph, but it's based on it is position elements are just based on the container, based on their container. So if we put it here, say based on the container. But he doesn't have any container here, right? Position absolute here, and default placement. Default placement. Here's a question: what happens if you set position absolute but don't give it an anchor by setting top, left, right, and bottom? So here's a playground to see if you can figuring out what it's doing. Position absolute and stay blue. It say, hey, this element that is absolutely, if I don't specify is the top, bottom, those properties, I'm gonna be used now is the flow of that. I'm gonna be used now is the position there. The position in which I anchor that. If we don't give our absolute elements an anchor, it sits in its default inflow position. I think of it as inheriting its default position from flow layout. So if you don't specify now, if an absolute element you don't specify is any top property, it's gonna inherit, okay, it is default position from the flow layer. See this for yourself by removing absolute position, and notice that the element sits more or less in the same spot. So if you remove this, now those elements are gonna sit more or less in the same spot. Unlike this, where now is inheriting that. It's inheriting its flow in flow position from the layout. It has one of other effect though. It caused the absolute element to stack on top of the surrounding text, which takes us the second aspect of absolute position. Effects on layouts. This position is a bit of less obvious, but maybe even more important. When we set something to be position absolute, we pull it out of the flow. When the browser is laying out elements, it effectively pretends that absolutely positioning elements don't exist. They incorporeal. Okay, they are incorporeal. You can stick your hands right through them like a hologram or a ghost. Because the using is now position absolute for that. To drive the point home, here are 3 paragraphs that has been set to be absolutely positioning. And when you put it this, when you define this, because at the end of the day, this positioning and relative and absolute positioning is unlike the normal flow. It's gonna put elements in the same pixel. That's what is happening is this. That's a good question. It's like, if I do this, what element do you get? I'm assuming that I'm gonna get is the last one. Exactly. So the intuitions works. Okay. Because now it's more at the top of the element. Okay. To drive the points home, we are 3 paragraphs that has been set to be absolute position, like this. This is effects on layout. We pull it out of the flow. The browser starts by putting the first paragraph in its natural position at the top of the document, but because it is absolute, it still considers that space empty. Next, the second paragraph gets added in its natural position, which is also right at the top. Since the container is effectively empty, this process will continue for each providing absolute elements here. Being able to take elements out of the flow is super handy. Anytime you want an element to be floating above the content, like a tooltip or a drop down or a model, exactly. For a model or a drop down or a tooltip, absolute position is your friends here. Collapsing patterns. While often the ability to take some elements out of the flow is useful, there are times when it can be annoying. Consider these elements. In this example, we have a pink box sitting within a black border. When we toggle on that position absolute, you will notice that the pattern collapses. The pattern collapse when we toggle on that position. Okay, exactly. The pattern collapse on that position absolute. You'll notice that the pattern collapse down so that it's 8 pixels tall, 4 pixel top border, and exactly 4 pixel top border, top and bottom border. Why does this happen? Well, in terms of flow layout, the parent is empty. Okay. In terms of layout, of flow layout, the pattern is empty. remember, absolute elements are like holograph, so they are not gonna be wrapped then. They don't really exist, and they're gonna be anchored to the container, right? And the reference is the container. It is container. They don't really exist, and since these pairing elements have no other childrens, it is as if it was empty diff, the right tool for the job. You may be wondering, how do we fix this? If there is a way to stop the pattern from collapsing while still using absolute positioning on the child. Wait, what? The right tool for the right job. You might be wondering, how do we fix this? If there is a way to stop the pattern from collapsing while still using absolute position on the child, unfortunately, I'm not aware any way to do this. At least not without resorting to the bunch of hacky GS. But I sort of think it is the wrong question. In general, absolute position is intended to be used in situations where we don't want it to affect the surrounding layout. Okay. Makes. So when you don't want to affect the surrounding layouts, then you might use absolute positioning. If you find yourself running into this problem over and over, it is likely that you are reaching for absolute positioning in situation where another layout modes, flex and grid, will be more appropriate. Absolute zeros.
So here we have an absolutely positioned element. As it stands, it's just kind of hanging out near the top left corner of the viewport. And I have this display property. And I'm curious, I'm going to ask you the question. What do you suppose happens if I change this element to have a display property of block?
Well, if you change that as a block, it will take all the available space horizontally, all right? AKA the border will be now so the border will be now is to the right element, right? This is the intuition. Is this right? Display block? Well, according to this, if this particular element that has this selector behave as expected or as we think it is this. It's gonna take all the available space, horizontal space. But the thing here is that it's gonna take all the available horizontal space or the horizontal children's space. I'm gonna take all the available space.
We can try it. And nothing really changes.
Again, because it's now using its position absolute.
And I suppose it makes sense, right? We're applying these styles to a div, and the default value of display for divs is block. So then, what do you suppose happens if I change it to inline? Well,
so if I change that to inline on this position absolute, I don't think that nothing will change.
We can try that too. And anticlimactically, nothing happens. And this is one of those common points of confusion for people. So I really want to take a moment and talk about it. Different layout modes use...
Okay. Because now we're talking about is different layout modes. Okay? Different layout modes as well as the position of this element.
Different properties in different ways. We've been talking a lot about flow layout in this course so far, and in flow layout, display block and display inline are vital ingredients to the ultimate layout for the element. With positioned layout, it doesn't quite matter as much. When we're talking about absolute positioning, this value isn't used at all. The algorithm doesn't care what the value of display is unless we set it to none. If we set it to none, then it hides, like it does in every layout algorithm. But in terms of display inline, display block, that distinction doesn't make sense. There's no such thing as a block level absolute element. Where this gets a little bit muddy is around relative positioning, because with relatively positioned elements, you actually can change the display value and it has an effect. Relative positioned elements inherit a lot of their layout from whatever the layout mode otherwise used is. Relative is kind of like this weird middle ground between position layout and whatever else it is, whether it's flow layout or flexbox. So that's like a bit of an exception. But when we're talking about absolutely positioned elements and sticky and fixed, and in general just every layout mode, every element is rendered using a single layout mode, and different layout modes use different properties. So this
Okay. In different layout mode, use different properties. Different layout
property
mode
has
use
no
different
effect
properties.
for absolutely positioned elements, but then that opens a new question, which is how does an absolutely positioned element determine its size, right? Because in flow layout, a block level element is greedy and will expand.
Exactly.
An inline element goes with the flow. We've talked about that. What about absolute elements? Well, we can kind of get a sense from what we're seeing over here that it's closer to inline, but not exactly. An absolutely positioned element wants to be as small as it can, because in general, this is kind of what you want, right? Usually absolutely positioned elements are meant to kind of stick in a given spot, and you don't want them to be growing. You kind of just want the element to be whatever it is in whatever place you put it. So it's going to shrink to fit the content. But what if we have a lot more content? And this is where it starts to get a little bit interesting. I've given it a distance from the left, but I haven't given it a distance from the right. And you might think it would just grow and grow and grow and grow, but it actually stops once it hits the right edge of the viewport. To be a little bit more precise, it's stopping when it hits the edge of its containing block, and this is one of those hidden mechanisms we're going to talk about much more very soon. For now, we can just think of it as the viewport. So this is kind of interesting, right? It grows until it reaches a point where it can't grow anymore while still fitting in the viewport, and then it forces a line wrap. And if I was to add a distance from the right, if I was to say right 32 pixels, well now, instead of it going all the way to the edge of the container, it's going to go until it reaches 32 pixels away from the container, and then it line wraps.
Right of the container.
What do you suppose happens, though, if it can't line wrap? So let's imagine that I remove all of the spaces, right? And we're going to talk much more about this algorithm in the future. Essentially, the way the line wrapping algorithm works is it looks for soft wrap opportunities. And this is things like spaces or dashes, right? Anything that it can wrap without kind of breaking the flow of the words. So when I do this, and I'm almost done here, I do kind of break my editor, which is a little bit unfortunate. Maybe this will be fixed by the time you watch this. But something interesting happens over here. The box, right, the rectangle is still going to take up the same size. It's going to be 32 pixels from either edge of the viewport, but the content is now introducing this horizontal scroll bar. And it makes sense because we've given it kind of an impossible situation. We've said that it should be 32 pixels from the left, 32 pixels from the right, and then it should also contain its contents, because that's how elements like to work, right? That's how the algorithm works. It grows and shrinks as needed based on the content size. But it can't really do that here. It can't grow to contain the contents because the contents are too large. So that's kind of a lot of independent pieces of information. Let's see if we can connect those dots and tell a compelling story about what this algorithm is doing. And I think the first takeaway I have is that absolutely positioned elements are extremely compliant. And what I mean by that is they really want to follow the properties that we give it. So in this case, I have this really large, really unwieldy bit of content, but the box is kind of staying firm at exactly the priorities that we've given it. So we've said left 32, right 32, and that box is stable. And the same thing is true, by the way, if I use width instead. So if I was to say width 200 pixels, our box is going to be 200 pixels wide no matter what the content is doing. In general, it will try and line wrap the content, right? That's kind of its ideal, but it always makes sure to respect the priorities that we give it. If we give it some leeway though, so if I don't set a width and I don't imply a width by setting both a left and a right, well then the box is going to grow as large as it has to contain the contents within its own environment. So this box doesn't want to break out of the viewport, right? It doesn't want to get so large that it doesn't fit, but it is willing to allow its content to overflow. So if the content is really big, if there's no white space, or maybe it's a really large image, then that image will be allowed to overflow without the box itself changing dimensions.
But this is not how to. Okay, so how to at least have a huge overview of that. centering trick. So we have seen how we can position an element by specifying a distance from the angle like this, right? Distance from the top edge, top and left. Absolute positioning elements have another trick up their sleeve. We can use this property to center the elements as well. Yes. So don't we have any? There you got it. So in order to center this, you can say, hey, this box, all right, that I want to put now on, that I want to break the normal flow. And if I want to center this, because at the end of the day, this is a box, I can use margins to do so. I can use something like this, for example, to center the element horizontally, or to center the element, vertically and horizontally. Or you can say something like this. I just want to center this element horizontally, vertically. But remember that at the end of the day, it's because we are saying that this element will be now is absolute, and the point of reference will be the container of that element. In this case, I'm assuming that this is the body. Okay, so we can spec this a little bit and say, hey, this is now the body. All right, diggy. There you got it. Here it is the body, right? So yeah, the body, if this is actually collapsing the absolute values, because if you say now, for example, the height of this will be it will be now 100%. You will also need to specify that the HTML element here that is embedded, their height is now 100%, right? And it's actually taking that particular element as expected, right? So now that we are here inside of this iframe, and it's actually it refreshed that as it is. So but in any case, here we got this, right? And now this particular element, because it's collapsing, we are saying, hey, we're gonna position absolute collapse elements, and say, hey, because I don't have any content in the body, I'm gonna put now this as a reference of the pattern element here, and they take all the available space, or the finding here is this is the property that you can go with. All right, so you don't define this, it won't do anything that's interesting. But if you specify now the pixels where you want to now put this, whether on the right, top left, top left will be 0 here. Okay, so you're saying these elements, hey, I do want it to be is at 0 position, left, right, at 0, well, and bottom at 0, and then do this. What in the F?
So this is kind of interesting. We have this pink box, and we haven't given it a size, but but we have given it a distance from each of the 4 cardinal directions. And so what it has to do in order to comply with this is it has to dynamically calculate a size that essentially is the entire width of the viewport minus 100 pixels and the entire height minus 100 pixels. And this is all well and good, right? We're able to be strict with the position if we're willing to be loose with the size. But what do you suppose happens if we try to be strict about both of those things at the same time? Maybe we've had a bad day and we want to exact a little revenge on the computer. So let's see what happens. We'll give it a width of 100 pixels and a height of 100 pixels. Thankfully, the computer doesn't explode, but we don't really get, we're not complying with all of these requirements, and of course we're not, because it's impossible, right? Unless our viewport happens to be exactly 200 by 200 pixels, there's no way for it to be 100 pixels wide and stretch the entire distance so that it's only 50 pixels away from either edge. And essentially the way that it resolves this conflict is it listens to top left. It prioritizes these two sides. Usually, like those, that's the kind of origin point, and we'll see a lot of this throughout the course.
Exactly,
things
the origin
originate
point
from the top left. So those are the kind of prioritized sides. And it doesn't, the order doesn't matter. Like I could move top and left lower. It's not a matter of like whichever ones come first. But something interesting happens with this impossible condition if we introduce auto margins. And so we saw this a little bit in flow layout. If I set margin auto, our box moves to the very center of the viewport. And this isn't quite perfect, right? Like if we get really small, then the fact that we're still 50 pixels from the left starts causing problems. So in general, we want to set it to be 0 pixels from each side. That way it remains centered as long as it fits in the viewport. But this is kind of interesting, right? And I think it's worth revisiting the logic we talked about with auto margins in flow layout. Essentially how this works is the auto value is a hungry value. So it's going to try and grow as large as it can.
The auto value is a hungry value.
And because we're setting margin to all 4 sides, right, both the left and right are both trying to grow as much as they can, and it kind of forces the element into the middle. In flow layout, this only works horizontally. It doesn't work vertically, but with positioned layout, with absolute positioned elements, it works in both directions, which is pretty darn cool.
The inset property. As we saw, the centering trick requires setting all 4 edge property to the same value, like this. This feels very tedious, and modern CSS has given us a more terse way to accomplish this. Inset 0. The inset property will set all 4 edge properties, top, left, right, and bottom, to the provide value here. Okay. Does it take percentage? No. It takes only pixels. Okay, this is equivalent to say all of this. This property is supported in all modern browsers. Can I use say that it's available for 92.6 of users? If you need to support Internet Explorer, you should keep using the top, left, right, bottom combo. In this lesson ahead, we'll keep using top, left, right, bottom instead of inset. But this is only because I have gotten accustomed to using inset when originally created this lesson. Going forward, I use inset regularly, and I suggest you to do as well. Centering trick. My mind hurts a little bit, I must admit. And then containing block, stacking context, containing block, stacking context, and fixed position as it is. So that'll be all for this video. Take care. Bye bye.